Da 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 da. Today we are learning more chemistry and what's concentrations and solutions is all about. If you've gotten this far, you know that we are going to be working with a lot of formulas. So you'll need your periodic table, a calculator, some paper, a pencil, a glass of water, whatever, to work on this. So today we are doing more chemistry. Welcome, welcome. So why do we need to understand solution concentrations? Well, for one thing, we see it in our stores all the time. If I want to get 5% vinegar, which means it has 5% acetic acid, if it says 5%, that means that I can use it for pickle making. If it's too small on the acetic acid, can't do it, but if it's at 5%, I can make my pickles. Also, in our hand sanitizer, which is very important now, so much of it has to have a percentage of alcohol to be classified as a hand sanitizer that we can use to kill those bad viruses. There are 4 major measurements that we will use. Well, actually, I use one of them, maybe 2 of them. One is percentage by mass, one is percentage by volume, one is molarity, and the other one is molality. Very little difference. I don't use this one. I'm just telling you. One thing that we have to remember though, in water, 1 milliliter is equal to 1 centimeter cubed is equal to 1 gram. Pretty cool. I wonder if they use that in the SI system. Oh, I digress. Anyway, another thing that we must remember, and we'll get to it, is molarity equals moles per liter. Very important, moles per liter. So let's continue on with a practice problem. Are you ready? If you're not ready, please stop the video and get your materials, which includes a periodic table, a writing utensil, a paper, and a calculator. Thank you. So let's do the first one. Example, percent by mass. So here is a word problem. It says find the percent by mass of sodium bicarbonate in a solution containing 20 grams of sodium bicarbonate dissolved in 600 milliliters of water. So what we do is we decide what is our solute. Our solute is the 20 grams of sodium bicarbonate. The solvent is 600 milliliters. Now, in previous sheet, I told you that there are 600.0 grams also. So the whole solution is going to have a total mass of 620.0 grams. 20 plus 600. Didn't even need my calculator for that one. So to find the percent mass, just like anything else, if I have percent mass, I'm going to take my 20 grams of my sodium bicarbonate divided by the 620 grams of the total solution, and I'm going times 100, and I will find out what my percent is. I take my calculator, I turn it on, 20 divided by 620 times 100, 3.23%. Recap, solute, what I added in, solvent, my water, added together, and I got my solution. That's not so bad, is it? Well, let's turn one by volume. Kind of the same thing. I'm going to make a solution that contains 35 milliliters of ethanol dissolved in 155 milliliters of water. My solute again is my ethanol. (155 milliliters of water). Together, I have 190 milliliters. So percent by volume, I will take my 35 divided by my 190 times 100. Calculator. 35 divided by 190 times 100. 18.4%. Now I'm sure that is not correct because I'm not using significant digits, because I only have 2 significant digits with my 35, so my answer would be 18%. Up here, I had 3 significant digits in my 20.0, so I can write 3.23%. How are we doing so far? Not too bad, is it? Well, good. Let's continue on to molarity. Molarity is something that you've seen before. It'll tell you in an experiment that we're going to use a 1.00 molar solution of some acid or something. So that's exactly what we're going to be learning today, what that means. I've written out some of this material already, like for example the molar mass of glucose. So we're going to calculate the molarity of an aqueous solution containing 40 grams of glucose in 1.5 liters of solution. All right, let's talk about some of the math here. The math is this. The word in usually means division, and the word of usually means multiplication. So let's look at that a minute. If I have 40.0 grams of glucose in 1.5 liters of solution, which is probably a water solution. I'm just going to write that water to give me an idea that I know it's a solution. I need to determine the moles per liter. I have grams here and I already have liters on the bottom. So half my job is done. My labeling is correct for liters on the bottom. I'm not going to address that. But what I need to do is I need to find out the number of moles. So I'm just going to use a little bit of dimensional analysis here. And I have grams of glucose. So this is grams of glucose. I've written that down as 180.1572, which is 1 mole of glucose. Now I have moles per liter, which is what I want when I want to find molarity. I take my handy dandy calculator off to the side here a little bit so I can see my work. So I'm going to take 40 divided by 1.5 divided by 180.1572. And I get you can read that, 0.148. Considering there's only 2 significant digits for my answer, it's going to be 0.15 molar. We use a big M for that, molar of glucose solution. I'm sure you recall seeing this symbol somewhere on previous labs. Let's try one more of those. Here's another one. How much calcium hydroxide in grams is needed to produce 1.5 liters of 0.25 solution? Whoa, we have a lot here. Let's look at if we can figure this out. This is more what I would probably do if I'm going to prepare calcium hydroxide for you to use in the classroom. If I'm supposed to have a 0.25 molar, and I know I'm going to need approximately 1.5 liters, how many grams am I going to be needed to put in solution in 1.5 liters to make sure that you have the proper solution to do your experiment? So as I said before, the word in means divide and the word of means multiply. So if I want to have 1.5, again, we're going to use our dimensional analysis, 1.5 liters of, so I'm going to multiply. This is my dimensional analysis. I have this molar right here. This means I have 0.25 moles of calcium hydroxide in 1 liter. Again, now my liters are going to cancel out, my labels are going to cancel out, I'm in moles. So my next step is to determine grams. Can I go from moles to grams? Of course I can, and I've already calculated what the molar mass of calcium hydroxide is. So I would do 1 mole of calcium hydroxide is 74.0926 grams. Take my handy dandy little calculator over to the side here. 1.5 times 0.25 times 74.0926. Enter. I get 27.784725. However, my problem only indicates that I can use 2 significant digits, so my answer would be approximately 28 grams of calcium hydroxide is needed to make that 0.25 solution. We're going to do one more just to help you go out a little bit differently. One of the first slides that I showed you in this PowerPoint was a dilution, and I have the dilution equation written here, and it's you're going to dilute it. So when I order acids and stuff, I usually get like a 5 molar or an 18 molar or something like that, because I can always dilute it with water. Remember, it's cheaper to dilute it. It's cheaper to send it in a strong dilution or a strong concentration, and then I can dilute it. I don't have to pay for that water shippage. So I do that a lot. So the question is, how much 5.0 molar nitric acid in milliliters is needed to make 225 milliliters of 1 molar nitric acid? This is probably my dilution equation. I take the 5, how much, it's either or. I take the molar times whatever volume I need to get 1 molar times 225 milliliters. I math it. 225 divided by 5, and I would need 45 milliliters of this added to that to make this. So if I have 45 milliliters and I want to make a 225 solution, I would take the 225 minus the 45, which would be 180 milliliters of the water. So this would be of the 5.0 molar nitric acid. So I would put 180 milliliters of water into a beaker or Erlenmeyer flask, and then I would add 45 milliliters of this 5 molar nitric acid to that 180 milliliters, because you always add acid to water. You never add water to acid. You always add acid to water to get that 225 milliliters of solution. So, hopefully that helps you in your assignment that you'll be getting. And it's been a pleasure showing you how to do these things. And I hope that you have a better understanding of how to do the calculations for concentration of solutions.